Good morning to all. My name is Dr. Janardhana Rao, working in Mr. Veterinary Engineering College. I'm also a professor. Today, my topic is OS structure and applications of OS. I will discuss all these things in deep. In this structure, in this operating system structure, the set of jobs in memory can be the subset of the job kept in the job pool. The operating system picks and begins to execute one of the jobs in memory. Eventually, the job may have to wait for some task, such as an IO operation, to complete. So, as I explained in the previous classes, so whatever you write the program, whatever the program you write, that lines, each line is an instruction only. This is instruction 1, 2, 3, 4, like this. Then suppose there are 100 instructions are there, 100 lines are there, 100 instructions are there. So the OS will manipulate, rather you can say, each instruction will be executed by the OS through the microprocessor. So the OS will send instruction one by one instruction to the microprocessor for execution. That's what. So OS means the program. There are some, as I explained in the previous class. So this is your OS. There are certain programs are there, some programs. These programs related to process management, and some programs, all these programs, they are related to memory management, like this. So here the OS, what it does, it will send instruction to the microprocessor in the motherboard. It will send one instruction to microprocessor for execution. That's it. Rather, you can say each instruction, you can say as a job or a process. So see, as you know, when you did the program you wrote, the Java program. So when you want to execute it, what simply will say run. You click on the run. Whereas when you press the run, first instruction will be brought into the microprocessor for execution. Like this, whatever result is coming after first instruction, so that will be kept in one of the buffer register in the microprocessor for the further use. So if some instruction or any job, we can call it each instruction is job only, is a process. Suppose some instruction is required some input. So suddenly OS will keep that instruction in the wait state or IO state. So it will be waiting for some input. So like this. So eventually the job may have to wait for some task, such as an IO operation, to complete. In non-multi-program system, the CPU should sit idle. Suppose if we are executing the program, suppose it is not non-multi-program, single program. So it will wait for the another instruction to come in the microprocessor. That is, one by one instruction, one instruction will be completed till the second instruction comes into the microprocessor. Till the time microprocessor has to wait for the instruction to come. So that's what the ideal state. So in multi-programming, in microprocessor never sit idle. Because it will keep on working, keep on engaged with the jobs or instructions to execute one by one. So one instruction, the operating system simply switches to and executes another job. So if some instruction is waiting for the input, so that will be kept in the waiting state for temporary in the buffer state, and waiting. It will take and automatically go to the second instruction to execute. So when the job needs to wait, the CPU switches to another job, and so on. That's what I told. Eventually, the first job finishes waiting and gets the CPU back. So as long as at least one job needs to execute, the CPU is never idle. So this is the advantage of the multi-programming. So multi-program system provides an environment in which the various system resources, example CPU, memory, and peripheral, are utilized effectively, but they do not provide for user iterations with the computer system. So in the multitasking, multi-programming, CPU will be always busy with some execution. If some is waiting, it will take another job. So that's why in multi-program maximum utilization takes place of the maximum utilization of the CPU. So the second one is time sharing. Time sharing is a logical extension of the multi-programming. Here, there is as we see in the latest computers, we have got multi processors. So in the multi-processor, so instead of one CPU, there will be three CPU of i3 or i5, i7. So here there will be time sharing for the memory. In time sharing system, the CPU executes multiple jobs by switching among time sharing. Time sharing is a logical extension of the multi-programming. In time sharing system, the CPU executes multiple jobs by switching among them, but the switches occur too frequently that users can interact with each other each program while it is running. So that is time sharing process. The user gives instruction to the operating system or to program directly using an input device such as keyboard, mouse, no touchpad or touch screen, and waits for immediate results on a output device according to the response time. So that is time sharing takes place like this. So time sharing and multi-program require that several jobs be kept simultaneously in the memory. So as we explained, the program is nothing but you wrote the program you wrote this program. Each line is one instruction. So you keep on when you run simply the OS will monitor and sending the first instruction to your microprocessor. This is nothing but uh, time uh, time sharing multi-program required that several jobs be kept in simultaneously in the memory. So it is as good as memory. So suppose one process is sharing time for taking some jobs here, and another processor. So suppose in this one there are three processors are there. So there will be time sharing. First, this CPU will be taking this instructions and executing. Meantime, time will be allotted to the another CPU to take another jobs from the memory. So like this, time sharing will be there. If several jobs are ready to brought in the memory to memory, and there is no enough room for all, then the system must choose among them. So there is system will not choose anything. Only operation system OS will be controlling which processor should share which job. That's final. Making this decision involves job scheduling. That's called job scheduling. Job scheduling will be done by the microprocessor OS only because, as I explained in the previous classes, OS is nothing. OS is not a like a simply is not a hardware. It is a OS is a full of programs. These are OS. This is OS. In this one, there are number of more than 1 lakh or 2 lakh programs are there. These programs are in the shape of .exe files. So some programs are related to your program execution. This is program execution. So you can say process management programs, and some programs that is memory management programs. So as I want to explain to you, the OS is a package. Is a package. In this one, lot many programs are there, compiled programs. I will teach you how to prepare OS also. OS is first what user wants. We write the program either C and Java. After that, after compilation, that program will be added one package. So like this, suppose for keyboard programs, for any program, for any user's requirement. First, you have to write a program, then compile it. The compile file will be added to the OS. Start how the OS is prepared. So this program once you install in the system, and the system will automatically invoke by the whatever the user wants. User wants suppose you want to save a program. So that saving programs, how to save and all these programs are there in the OS. So once you write a program and enter save, automatically that programs will wake up and help the user to save the program in the hard disk. That's what I want to say. So that is called making making this decision involves job scheduling. Job scheduling. Okay. So when the operating system selects a job from the job pool, it loads that job into memory for the execution. First of all, what job should be done, what sort of job should be executed, that will be decided by the user, and automatically it goes to your OS. OS will bring that job into RAM, and from RAM into your microprocessor. That's what is serial doing. So once you write any C program or Java program, that will be after writing, we will compile it. After compilation, we go for saving in the hard disk. After saving in the hard disk, you will go for the execution. When you are executing again, that program what you wrote and saved in the hard disk, that will be brought back into RAM. Then one line by line will be brought to your microprocessor for execution. That's what sequence will be there. If several jobs are ready to run at the same time, the system must choose which job which job must run first. Making this decision is called CPU scheduling. So CPU scheduling is a technique. So we write some programs and keep in the OS, and these programs will select which job should be given to your CPU. Your CPU means your microprocessor. Your microprocessor. This is your microprocessor. So this is your core core component of your hardware. So whatever programs you write, that programs either Python or Java, this is each line. Each line is a line. Each line is a instruction. Each line. So here, so the CPU once CPU is ready for execution, the OS will bring one of the instruction to the OS. So OS, I mean your microprocessor. The microprocessor will execute that instruction. That execution one by one. OS will be monitoring. OS will be monitoring to bring instruction to the microprocessor. So this is called how microprocessor to behave, how the microprocessor to act, and these that will be decided by the programs in the OS. This is OS. Instead, there are number of programs. Some of the programs related to the process management. This process management is nothing but execution of the program. So the this OS will monitor. That is nothing but how microprocessor should work. That is called scheduling. CPU scheduling. CPU is a hardware. So how your hardware should work. That programs are there in the OS. These programs will wake up and get the job done. That is job done is bringing one instruction to the microprocessor and get the output, and they'll be saving the temporary registers in the microprocessor. So this is what. So that is finally running multiple jobs concurrently requires that their ability to affect one another be limited in all phase of operating system, including process scheduling, disk storage, and memory management. So as I told, OS is a OS. This is OS. There are number of programs. Some programs are related to your saving. That is memory management. Some programs related to your process management. Some programs to monitor how to save, where to save, and all these things. So they will be monitoring the whole soul of your system and what user wants, and the corresponding programs in the OS will be invoked, and automatically the job will be done by the hardware. That's what the OS will do. Okay. So we'll see what are the operating system do. What operating system will do. See, an operating system is a construct that allows the user application programs to interact with the system hardware. Since beginning we are discussing OS is the everywhere, OS is everything, and what user wants, that will be done by the OS through the hardware. So OS directly interacts with the hardware, what user wants. that will be getting done by the hardware. The operating system by itself doesn't provide any function, but provides an atmosphere in which different applications and programs can do useful work. So what since beginning I'm telling, OS is a OS is a package. It is a package. Inside there are number of programs. This number of programs are in the shape of .exe, and these .exe files. Okay, these .exe files only will get the job done through the hardware what user wants. So we'll see what are the major operations of the operating systems in this lecture, and we will see what are those operations. So the major operations of the operating system are process management. The process management already we discussed now. What is process management? Process management. What is process? First of all, process is some operation. So here the operation is nothing but I already explained. This is a program, either Java or C or Python. Each line is a instruction. Int A, int B, C is equal to int C is equal to A plus B. Like this, we write a program, C or Java. So this is there may be 100 lines or 1,000 lines in one program. So after writing the program, we go for compile. Once you compile the program, you will get the .exe file, and the .exe file we will save in the hard disk. That's what normally we do. So after saving the program, again we'll go for execution. So once the execution, you will execute or run this program. Once you press run, automatically the first line will be brought to the microprocessor for execution. This is called program under execution is called process. Program. This is a program. This is a program, and we are executing line by line. So this is called program under execution is called process. This is called, it is a process, processor. It is process. It will process. What it will process? It will execute the instructions line by line, step by step or line by line. So program under execution is called process. So process management means this program, it is process. It is management. Who is managing? OS is managing. So we call process management is a primary job of the operating system. It will execute the program in a systematic way. So this is called process management. Okay. Next one is memory management. Memory management means, so once you write a program or any document you write, so once you want to save in the hard disk, that will be taken care of the OS, and it will save in the hard disk. Where it is saving, as you know, in C drive, D drive, E drive, there are number of drives in the hard disk. So it will save this program in the either C drive or D drive, that will be saved here. So that is, and the OS there are as I explained, basically OS, there are some memory related programs are there. These programs will take care of where to save, what is the size of this program, and all these things will be done by OS programs only. So we call memory management programs or memory management. Whatever program you want to save, that will be taken care by the OS. This is your OS. OS means OS. What is OS? OS is full of programs. .exe programs are there. These programs will take care of and save this data in the hard disk. That is memory management. Memory management also taken care by your OS. Next, device management. So device management means, okay, I will explain this one. Device management means whatever device you are connecting to your system. Suppose you are connecting a mouse or USB or any external peripherals you are connecting, the printer and the keyboard. These are all peripherals connecting to the your system. So once the device is connected, the device should work. So once you are moving mouse or your pen drive or your anything, whatever external device you are connecting to the system, so that device to work, in the OS itself, there will be some programs related to your device. Otherwise, OS will not accept. OS will not accept that one. So, as I explained in the previous class, so apart from the OS, there will be another application programs. That is, so corresponding device drivers will load. Okay, you connect the device and device drivers and OS. Then only OS will understand your device. So device drivers also software, and this device drivers will identify and interface. This program will get interface with the corresponding program in the OS. That suppose printer. So you are connecting printer here, and with the corresponding printer device drivers will be there. The device drivers will be connected here. In turn, this device drivers is a software that will be interfaced with your OS. In the OS, there are certain programs already we loaded in the OS. So this will be interfaced here. So then only your device will be identified by the OS. So then your work will be done. So that is called device drivers. This is and file management. The file management in the computer. So just you can see this one. What are they in this one? So file management. So we'll see what is the file management. File management means the system. In the system, the OS will consider everything as a file only. Whatever you type, whatever you save, it will consider as a file only. Real file. So once you save this file in the hard disk, there will be systematic procedure will be there. Where you are saving, where it is saving in the hard disk. It is a hard disk, and you want to save down some data. See here, this is C, D, and E. Where you are saving the corresponding, as you know this, in this one, each line, and just you see, address will be there, starting at this 000. There will be each line, 8 bits will be there, 8 bits data will be there, and where you are saving your file, that will saved here. Where you are saving here, that is file. Suppose you saved here. Okay, so where you are saving, at the end of the hard disk, there will be a file blocks will be there. File blocks. In the file blocks, where actually your file is saved in the hard disk, the corresponding file address and file name both will be saved in the file block. So that is we use the data sections, your trees and all to indexing of the files. We'll see in the later classes how this file management done by OS. Like we'll see this. This is here. Once file is saved in the hard disk, where it is saved, quickly it can when you want to retrieve the file from there. So OS will go to this file blocks and check the file name, what file you want to open, and where the file is saved in the hard disk, and everything will be checked from the file blocks and go to this address and get the data from hard disk to our RAM so that we can see on the screen. This is what file management. Everything is done by the OS only. So OS means inside the OS there are lot many programs. This corresponding some programs are there. These programs only manipulate this file management. Next, we will see this operating what our operations we discussed now. That is everything is just in a single diagram. That is your operating system and what jobs will you do, what operations will perform. One is process management. What is I already explained what is process management, memory management, and your device management and your file management. So these are the main operations of the OS. What the user want from OS. So modern operating systems are interrupt driven. What is interrupt driven means after completion of each instruction, there will be one one interruption one that come after completion of the each instruction. So modern operating system are interrupt driven. If there are no processes to execute, no IO devices to service, and no users to whom to respond, an operating system will sit quietly, waiting for something to happen. So that's what, because there is no work means you will simply sit. Same thing. Events are almost always signaled by the occurrence of interrupt or trap. A trap is a software generated interrupt caused by an error that, for example, division by zero or invalid memory access or by specific request from user program that an operating system device perform. The interrupt-driven nature of an operating system defines that system's general structure. For each type of interrupt, separate segments of code in the operating system determine what action should be taken. So, in this sense, there are 256 interrupts are there. There are some of the hardware and software interrupts are there. So, for simple example for the hardware interruption is reset. Whenever there is some problem in the system, automatically we go for reset the system. Reset. That is what is going on in the system. Everything will be stopped and system will be restarted. Restart. That is restart. That is reset. That is reset is nothing but reset of the system. Similarly, that is a hardware interrupt. And so similarly, trap is a software interrupt. After completion of the each instruction, the OS will be implemented. The execution is completed. So that is the thing. So dual mode and multi-mode operations. The dual mode operation in the operating system protect the operating system from illegal users, accomplish the defense by designating some of the instructions and as privileged instructions that can cause harm. The hardware only allows for the execution of the privileged instruction in kernel mode. So an example of privileged instruction is a command to switch to user mode. See, in the previous class also we have discussed what is kernel mode and what is user mode. So kernel mode means the user mode and kernel mode. There are two modes in the computer operations. In the kernel user mode means the user give the input to the he will otherwise he will type something to get the job done. So that is only the user do. So after that the kernel will take over and get the job done. Uh, Kernel is nothing but OS, operating system. Kernel means it is an operating system. Inside this one, what are the programs available? These are the programs. These programs are .exe. There may be lakhs of programs may be there. So some programs related to processment, some programs related to memory management, some programs interrupt driven. These all programs are there. So what I want to say, so the user only give the command or type something to get the job done. So this is your user mode. After user mode, automatically the OS will take over what user wants. So OS means inside the OS there are what program. These programs will take over what to do, what user wants. So corresponding programs will invoke one by one, automatically linked each other. Those programs will execute, and that is nothing but some program out of this OS programs in the OS programs. Some programs are very directly interfacing with the hardware. So we call kernel. This is called kernel programs. So there are number of programs are there in the OS. Out of this, some programs are directly interfacing with the hardware. So we call it the kernel. So automatically, what I want to say, see user programs and kernel programs. OS mode. This is user and kernel. User tries something, and automatically OS will get the job done. But ultimately, some of the programs will interface with the hardware. That's what I want to say. This called in the coming lectures we'll discuss what is microkernel and all. But now, so kernel means some of the programs are directly interfacing with the hardware in the OS. So this is called kernel. What user wants and the OS will get the job done through the hardware. So this is called kernel mode. So user mode, kernel mode. So the two modes of the operating system are user mode and kernel mode. Okay. So next, so dual mode and multi-mode operations. A bit called the mode bit is added to the hardware of the computer to indicate the current mode, that is kernel mode. If it is, that bit is set to 0, that is the kernel mode. I explain now what is kernel mode, what is user mode. If bit is set to 1, that is user mode. So that's what mode bit is required to identify in which particular mode the current instruction is executing. So explain that if the mode bit is 1, it operates user mode, and um, if mode bit is 0, that operates in the kernel mode. As I explained now, this is our user and this is our OS. This is our OS and user. So once user handover, in the sense, is requesting or asking to computer to do something. So you will write a program like this. After writing, you want to go for execution. You will submit for the execution. Execution will be done by OS, or you want to save some data. So that will be done by OS. Instead, that is, you can say, rather you can say OS mode only. So instead of saying OS, we call kernel, means kernel, it is core. What you call cores in the core programs will be there. These programs directly with hardware interface with the hardware. So that's what that user mode and kernel mode. So some of the programs in the user or your OS will directly interface with the hardware. So that programs are called kernel programs, kernel mode. So once the OS will take over from the user, so the kernel will come into action automatically. So this is, you can look at this one and we can see what is this kernel mode. This, if you look at this rings, kernel mode, ring 0, ring 1. These are all your OS programs only. So this is user mode. I already explained. User mode and kernel mode. So whenever the bit changes, automatically the bit, the mode bit is bit of the user mode is 1. This means that if the mode bit of the system's process is 1, the system will be in the user mode. So user only typing. So automatically whenever you submit or saving or deleting or any operation, that saving will be done by your OS. So in the OS, the kernel mode ring 0. These are the hardcore programs which can interface with the hardware. So this is that you can see that user mode and kernel mode. So user modes, you are writing something and submitting something. So when you are submitting, so automatically kernel will take over all the bottom levels task of the operations. If you look at this one, CPU, memory, IO, this is a kernel. Kernel is something different. It is a OS, part of the OS. So these some sort of programs directly interfacing with the your CPU, memory, and IO. This is actually CPU is your microprocessor. So microprocessor you cannot touch as a user. You cannot touch. Only OS only can touch. So in that also OS also some programs, specific programs, they are directly touching the CPU and memory, that are your hard disk, and input output. So these are all the actual hardwares in the computer. So this when you want to save something, only you can after writing a program or writing something, you simply press the button save. So rest of the job will be done by your OS, the application programs and kernel. Your kernel is the hardcore programs which are directly interfacing with the memory. So we call it the kernel programs. So all the bottom level tasks of the operating systems are performed in the kernel mode only. As the kernel space has direct access to the hardware. This is only what I want to say. The kernel space has direct access to the hardware of the system. So the kernel mode handles all the processes which require hardware support. So the main functionality of the kernel mode is to execute privileged instructions. All the processes and instructions that user is restricted to interfere with the executed in the kernel mode of the operating system. The mode bit for the kernel mode is 0, means for system to function in the kernel mode. So the mode bit is 0 of the processor must be equal to 0. So this is what kernel mode. So now you can see this one. So suppose if I want to save a file, or if I save something. So first of all, I will write some document or uh, word file. So after writing this one, this is I wrote in the screen. It is in the RAM only. It is in the RAM. After this, I want to save it. Simply, I will press button save button only. So now automatically this is you are in the user mode now. You have user mode. Once you press save, automatically your OS, that is kernel, will take over this one. So now it will save this file in the your hard. This is hard disk. Your hard disk. So C drive, D drive, E drive. So it will send the save somewhere in the D drive. So how it is saving? Because in the OS there are some programs. These programs will interface. These programs will take this data, whatever you want to save, that will take line by line to the hard disk and it will save there. After that one, this is what I want to say. So if you look at this diagram, user process executing, calls system call, then execute system calls and return from the system call. So what I want to say, this is a mode 0, mode 0, mode 1. Mode user mode 1, kernel mode 0. So simply want to save a file up to here, you wrote something, that is user mode. You are in the user mode. So after user mode, you want to save this data in the hard disk. So when from here, automatically the moment you press the button save, automatically user mode is handing over to your kernel mode. So now kernel mode that bit will be set to 0 from user mode to user mode is 1. So now there are some programs in the system itself, some system calls, that is write system call, write system call, write system call we wake up, and whatever data you want to save, that will be written in the hard disk. That system call is executing here. So after executing the system call, it will it will come back to again user mode. Once it is saved, it will return after the job is over, it will return from the system call to kernel mode to user mode. So so automatically the write is a system call which is available in the OS. So the save button, once you press the save, automatically this will wake up the program, right, which is available in the OS. So now it is a hardcore, write is a kernel program. So now it will write this data in the hard disk. That's what I want to say. So these certain programs are having the direct access to your hard disk. I mean hardware. That's what is I'm insisting. This is a system call working in the kernel modes. So when the computer system execute on behalf of the user application, the system is in the user mode. So, however, when a user application requests a service from the operating system via system call, via system call, system call, it must transition from user to kernel mode to fulfill the request. As we can say, this architectural enhancement is useful for many other aspects of system operation. As at system boot time, the hardware starts kernel mode. The operating system is then loaded and starts user applications in user mode. So this what is kernel mode and user mode. So as I will tell you one thing, uh, whenever you switch on the system, whatever the programs OS is saved in the hard disk by default in the C drive, that will be brought, the Xerox copy of the OS will be brought to the RAM. So that is called booting. So that is called booting. That is, your entire OS will be brought to your RAM. So whenever a trap or a interrupt occurs, the hardware switches from user mode to kernel mode, changing the mode bit start 0. So thus, whenever the operating system gains control of the computer, it is in the kernel mode. It means the operating system is taking over the complete control on the system. That's what interrupt I told. Interrupt means whenever one instruction is completed, automatically the trap is the flag in the hardware, the microprocessor. It will raise the signal. Then it means the transition takes place. So thus, whenever the system always switches to user mode by setting the mode bit to G1 before passing control to user mode. So this is there are two main reasons behind the switching between user mode and kernel mode, such as if everything were to run in a single mode, we would end up with the Microsoft issue in earlier versions of Windows. If a process were able to exploit one vulnerability, that process can then hold to control the system. Certain conditions are known as trap, the exception of a system fault, typically caused by an exceptional condition such as division by zero, invalid memory access, etc. Whenever this unwanted event occurs, then automatically we will get indication that trap is a software interrupt that will be raised. So operating system operations, timer. Operating system maintains control over the CPU. That what since beginning we are discussing. Must prevent a user program from getting stuck in the infinite loop or not calling system service, never returning control to that is nothing but a computer hang up. So to accomplish this goal, you can use timer. A timer can be set to interrupt the computer after a specified period. And this period may be fixed, for example, 1/60th second or variable. So a variable timer is generally implemented by fixed time clock. So our system should not hang up. The operating system sets a counter. Every time the clock ticks, the counter is decremented. Whenever the counter reaches 0, the interrupt occurs. For instance, a 10-bit counter with 1 millisecond clock allows interrupts at interval from 1 millisecond to 1024 milliseconds in steps of 1 millisecond. Before turning over control the user, the operating system ensures that timer is set to interrupt. If the timer interrupts, control transfer automatically to the operating system, which may treat the interrupt as fatal error or may give the program more time. Clearly, instructions that modify the content of the timer are privileged. But there is a specific most important thing is the trap. Whenever the counter counts automatically, that control changes from one mode to another mode. So we will discuss evaluation of operating systems in the next class.
Like, share and subscribe. Hit the bell icon for more updates.